The last inverse we need to talk about is inverse tangent. We've already talked about how to find angle measures in degree mode. We need to talk about it in radian mode, as well as looking at the graph and what the graph actually looks like for the inverse tangent. So to start off with, we're going to work with the graph. We know originally for my parent function, I'm just going to do one. Technically, we know that there's more like this, but I'm just going to go with one. It's a little bit easier to see, as well as the picture gets a little crazy. So this is going to be my original parent function, so this is just my tangent x. Like we talked about in the other inverse videos, with the inverse, our graph actually gets reflected over the line y equals x. So it's just a reflection line. Therefore, when I do this, my graph then comes out like this. So it comes out sideways. So this is going to be the inverse of tangent. So what changes here, our domain gets flip-flopped. Originally, our domain for the tangent values was limited in that we had vertical asymptote lines. Well, now we're going to have horizontal asymptote lines. So like the inverse sine and like the inverse cosine, the domain and range actually just get flip-flopped. So the domain goes from negative infinity to positive infinity, and then my range is going to, and if I'm just looking at just this one, it's going to go from negative pi over 2 to positive pi over 2. And the reason why is because, like I said, you'll have those horizontal tangent lines, one's at negative pi over 2 vertically and the other one's at positive pi over 2. And those are just going in our increments there. Now, the next thing I want to talk to you is about the actual, if I'm looking for a radian measure. I'm not too concerned about the degree measure. You guys have worked with that enough in that you can use your inverse tangent on your calculator. The inverse tangent of radians, though, if it's looking for an exact value, can be a little bit tricky when you're plugging that into your calculator. I'm sure not everyone knows what the decimal value of pi over 2 is. Okay, so that's why I want to talk to you about that. So let's say that I want the arc tangent. Remember, arc tangent is the same thing as the inverse tangent. What if I want arc tangent where it's undefined? So this is where I'm going to use that unit circle. And the unit circle is going to be very important in that I can find my radian measure or degree measure, depending upon what they want, using my unit circle. So if I look here at my unit circle, I need to find out, in case you're wondering, the tangent values are on the complete outside. Okay, so I'm looking for values in which tangent is undefined. So if I look here, I've got a value here, and I've got a value here. So if I'm looking for the radian measure, I know it's that pi over 2 and 3 pi over 2. If I was looking for the degree measure, your unit circle that you have actually has those true degree measure values. And you would know that pi over 2 is 90, and 3 pi over 2 is 270 degrees. Okay, so you're just looking for those values in which meets your unit circle. Now, if they ask you to estimate it, you can go ahead and plug that right into your calculator. That's no big deal. But if they're asking for an exact value, then you got to use your unit circle. So let's go with the tangent -1 of negative square root 3, and I want radian measure. So again, I go to that unit circle, and I'm looking for the tangent value in which it's negative square root 3. So I'm looking, this is square root 3 over 3, not working. Here's the square root 3, but it's positive, so it can't be that value. If I look over here, I've got a value at 2 pi over 3. So that's one of my values. But now I got to find the other negative square root 3 because they come in pairs. And it's right here, 5 pi over 3. So my final answer then for the inverse tangent of negative square root 3, 2 pi over 3 and 5 pi over 3. Now, remember that I don't want the negative value. So that 5 pi over 3 actually could be a negative pi over 3, I believe it is. And I don't want those values. I want the positive values just so that everyone is on the same page and we're always going counterclockwise to get those positive values.